Good afternoon. Today we are going to explain the method of trapezoid and how to find the area. And I will explain that via several examples and the background of the situation. So I may make more than one video to do that. So let me now go to the Microsoft whiteboard and we'll share my application here, guys, with the whiteboard Microsoft. So I don't know if it's clear now to see the actual whiteboard Microsoft. Now, guys, I am going to start explaining some of this important things about the idea of finding area using the uh, trapezoid method. So the first example, I would like to share some important things, which is going to help you guys starting with the trapezoid method. Let's say, guys, first of all, I would like to take the XY axis. I'm going to take this is Y axis, and this is going to be X axis. Y axis here, and X axis is here. If I take the function, let's just assume a function y equal to the square root of x minus 1. Well, you know, guys, that f of x means y. I'm just going to rewrite that for you. And according to the graph of this, basically, if I start with, well, we need to know that the domain in here, guys, I'm just making the domain is x and x such that x is an element of real numbers. So basically, we are going to take the radicand, which is the this is the radicand underneath of the square root. That's what we name it, radicand, and we make that greater or equal to 0. So greater or equal to 0 because it's in the numerator. So then I can say that this is going to lead that x is greater or equal to positive 1. I close the domain in here, just let you know that. And the graph, it's going to be divided. So if I start with the point, let me just start. This is my starting point. Always in the radical functions, we have a start point, if you remember that from the previous classes. So I'm going to have something like this. That is actually the y, which is represented by square root of x minus 1. The function is continuing, but as I said, there is a starting point. The starting point is here, which is I can name this point 1 and 0. Well, guys, if I say that my question is, I want to explain the trapezoid method first of all. So if I want to find the area under the curve from x equal to, let's say that area, just make it this way, under the curve from x equals to 1 to x equals to 6, for example. Just an example here, guys. So basically, I'm going to divide this to, if this is x1, so that this point is going to be x2, x3, x4, x5, and x6. So I just divide this to several pieces, guys. So I'm going to make it this way here, trying to create a trapezoid figure underneath of the curve in here. And maybe the first one is not going to be exactly trapezoid. It's going to be look like a triangle. So when I finish, actually, when I make a straight line from the bottom point and these points here, guys, you can see that it's not exactly trapezoid. It's close to be trapezoid. So if I use another color here, maybe I can choose another color. So the first one is going to be, if I make it this way, let me just go back and try to see if this is possible to have a line, which is, let me see if I can have more colors, maybe. Clear colors here. So I just make it this way. Uh, just a second, guys. So would like to make it like straight. I just want to make it a straight line, and I don't know if it's possible to make it exactly a straight line. Otherwise, I will let me just try something else here using some of the lines we have. Maybe we can have some lines here, and I can use, there is a ruler here, guys. And I don't want to use the ruler, but I want to use exactly the straight line, guys. I'm just trying to see if it's possible to find a straight line here. Otherwise, I will make it on my own. No problem. So let's go back and state that there is a straight line going. Sometimes when you do the straight line like this, it is just stopping here. So I want to move this guy here, for example, and make it exactly here. So that's, you can see that this is not exactly. And then the same thing here with the other straight line. And we'll make another straight line here, guys. Look at this one here. Let's make it this way if it's possible. And if I can try to move it using this small line, and then I will just move it here approximately if it's possible. So let me just see if this one is going to be shorter a little bit. I don't know if I can change the direction of it. Or maybe I will do it this way. Yeah, I may just see if this is going to be a different way. So I'm gonna make a straight line here. Maybe I can use this one here. So make a straight line here. Hopefully I can do it. I don't know. Sometimes it doesn't work here very much. Yeah. Looks a little bit strange, guys, this time. I don't know. Let me just try to make it this way. Here. Yeah, and then this one here, approximately also another one. Will just make things, sometimes it does work easily, sometimes it takes a little bit of time. Okay, so guys, let me just make it this way here. How about this one? And this one here, approximately. Let me just clean these two parts, last two parts. I want to make the line clearly a straight line so you can see the trapezoid exactly. So here's the other one, and the last one is going to be here like this, and the last one can be in here. Yeah, and then I can fill, guys, these areas with a different color. This is the top of the, like, we can use basically. So you can see that this area can be filled later on, no problem. But that's actually the top of the first one, which is a triangle, and this is the top of the first trapezoid, the top of the second trapezoid. We'll clean it up in here a little bit and make things easier. Maybe people can see that in a better way. So that's actually approximately, this is this small tiny area on top of the each trapezoid. So basically we have, and the other points I can put here like a 2 and 0. This is a 3 and 0, and this is a 4 and 0. This is a 5 and 0. This is a 6 and 0. So basically we try to find the area under the curve. According to what I showed you guys, let's just go a little bit to the top. So basically we have 1, 2, 3, 4, 5 different areas. So the first one is the area number 1, which is, I can name it area 1, and this is 2, and this is 3, and this is 4, and this is 5, guys. You see that? These are 4 different areas. Basically, guys, why we are naming this a trapezoid, because if I make a trapezoid for you guys, generally the trapezoid is 2 parallel lines and 4 sides shape, 2 parallel lines. The other 2 lines are not parallel exactly. So if I just make it this way here, guys, let me just show you. This is one type of trapezoid. I'm just going to try to make it a straight line so people can see that. In reality, just this one base, the first base and the second base, they are parallel. The rest is not parallel. Some of the trapezoid can be plotted in this way, and this is also a trapezoid, guys. If I just take a look of this and make another trapezoid, maybe a little bit close to the shape I have in here, and that is also another trapezoid. Well, guys, for the examples we have here, I can make it at the bottom a little bit here. Let me just show you another trapezoid here. Maybe I can do it this way. So if I have this way here, and the other one is at the bottom in here, which is parallel to it, and I connect these two lines together. Let me just make it nicer. So the line shows exactly a straight line. Sometimes it doesn't work. I will just show you guys this one here. And that one is going to be this way. Again, I am not very happy with the line I am plotting today. I don't know what's happening with my, yeah, not exactly. Okay, so maybe this one is not bad, and this one is like this. Okay, so guys, this is a trapezoid, and you can see, guys, that this base with this base is parallel. And this distance, guys, if you take a look of this distance, here, if I just will go up a little bit and show you the height of the trapezoid. This is the height of the trapezoid, guys. Do you see that? That's the height of the trapezoid. We name this height of the trapezoid. If I turn my trapezoid this way, I'm turning it this way, like this. So my trapezoid is going to be, as I'm going to plot it down here for you guys. Again, the last time I'm going to plot this trapezoid. So my first line is going to be like this, and that's a second line, approximately like this. And my base is going to be this one. And then my top, let me just make the base first. And that's a top in here. And this is actually the height we were talking about. Now this height, guys, because it is on x-axis, this height, we are going to name it in the future delta x. So this is the first base, this is the second base, and the height is going to be delta x. So if I go back, guys, to the same, I'm just going to go back to the shape I have. So basically, I can say that each of these, I'm just going to rewrite that and make things easier maybe. Each of these are going to represent delta x. So from here to here, which is the height, or from here to here, which is the height, or from here to here, which is the height, that's going to be a delta x. So each of these people are going to be delta x. So I'm just going to rewrite that and then make it that delta x in here, delta x in here, and then so on. So each of these are going to be delta x. So basically, what's the idea of dividing the area under the curve to several different areas? Which is, guys, I don't need. Do I need to put this one also delta x so people can see that? Maybe I can do that, and then here's delta x, here's the other delta x. So basically, I have equal delta x in each situation. And I can see that I can divide the area under the curve to basically 5 equal places. So I can show you guys in here the, if I go back to the same graph I have it here, people can see now that there's five different areas. As we know, guys, the general law of the area of the trapezoid, I'm just going to write it down in here, and then maybe we can start from here. So area of trapezoid, if I name that area, and I say that this is area of the trapezoid, area of trapezoid equal to base 1, and that's base 1 plus base 2. So you take the average of these two, base 1 plus base 2 divided by 2. That's it. And then you multiply that all of it by delta x, which is the height. You multiply that by the delta x, which is the height. We said that this is the delta x, actually. So that's generally, this is the area of the trapezoid. If I want to put it in like a small here rectangle, maybe nicer to have it in this inside the rectangle. I'm just going to move my rectangle a little bit nicer to make it here. And maybe I can move also this shape. If I can have this shape can be moved or it cannot be moved, doesn't matter very much. So okay, that's it. So that's an area of the trapezoid. Now guys, to find, because we have more than one trapezoid, so we have basically different, so we're going to go down and then try to use the same rule, which is the area of the trapezoid, but I will make it this way here, guys. So instead of writing down the area of the trapezoid, so we're going to just make it AT. And you know that base 1, guys, look at this. Here's base 1 means, like, if I take base 1 here, it's very short, it's 0 actually. So that's going to be, or f of 1. Well, f of 1 is 0 in here. If you can check that here, f of 1 is 0. So I'm going to take the height as a delta x, as I said, and base 1 and base 2, they are actually these lines. Well, this is base 1, base 2, base 1, base 2 for each of them. So I'm going to replace that base 1 by f of 1. So for the first one, for the first area, which is, I just mentioned it here, I'm just going to say that base 1 plus base 2, I will say f of 1, because it's 1 here, x equal to 1, plus f of 2, plus f of 2, and then that's going to be divided by 2, and then this one is going to be multiplied by delta x. And then I do that with the other places also. So second one is going to be, I'm going to open a bracket again. So that's going to be f of 2. This one is f of 2 plus f of 3. F of 3, because these are the points we are talking about. So we need to know the height here and the height here, which is the base of the converted trapezoid. And I will put in here, let's just use maybe I can use the black color, it's better here. So I will just divide it by 2 and multiply by delta x. And I can do that for the other ones here also, guys. So you can see I'm just going to adding this. So I have, this is the second area. The third area, will just simplify that because I want to write it down and I want to get to the law. Plus now, again, I'm going to have f of 3 plus f of 4 divided by 2 multiplied by delta x. Then I will say plus. Then I will take another one here, f of 4 plus f of 5, and that's going to be divided by 2. And then it is going to be multiplied by delta x. And then the last one is going to be f of 5 plus f of 6 divided by 2, and then I close the bracket and I multiply that by delta x. So basically, this is the area of the trapezoid we have. So you can see, guys, that there is some sharing piece of this equation, which is delta x over 2. Do you see that here, Gabs? I'm just going to mention that. So delta x over 2, that's it. And you can see that there is a delta x over 2. And you can see that this is delta x over 2, delta x over 2. That's a common, guys. Delta x over 2, this is going to be, I will take it out. So I'm going to rewrite that as a delta x. I will just rewrite that because it looks like this is my triangle. It's not looking very perfectly. A delta x over 2, and I open a bracket now. So this means that I have a actually let me just repeat writing down this nicer, guys. I feel that sometimes the lines I'm going to make, yeah. So now this is going to be f of 1 plus f of 2 plus, again, that's for the second bracket, f of 2 repeating plus f of 3, then f of 3 is repeating in here. So another f of 3 plus f of 4. Now f of 4 is going to be repeated again. So that's going to be f of 4. That's going to be plus f of 5. Then this f of 5 is going to be repeating again. So that's f of 5 plus f of 6. The last one is going to be f of 6, which is not going to be repeated. And then we close this bracket. So basically, this is the idea. Here we go. And I have this idea. So if I want to make this one as a law, I'm just going to make it inside a very big rectangle. But I need to just put down that area of the trapezoid in here. And I make it, this one is actually the reality of having the law of the trapezoid. If I just move it a little bit, make it nicer, so you can see that in here. So that's a area using the trapezoid. Now, before, let's go back a little bit to the point we started from, and exactly what is actually the height, which is we put it on x-axis here, delta x. How much is delta x? Well, we know that from the graph delta x, basically, guys, to be honest, the delta x is equal to 1 in here. I can see that. Delta x equal to 1. You can see that's a bit, because it's difference between 1 and 2, 2 and 3. So each of the delta x, if I can say that in here, that's going to be delta x equal to 1. So if I make it, let me just make it nicer. Maybe I can just make the triangle nicer. And I can say that delta x is equal to 1. But we have a law how to find the delta x, which is the width of the trapezoid. I will say that this is the width of the trapezoid. Delta x, I can write it down here. The width of the trapezoid, of the trapezoid, the width of the trapezoid. Now, it is actually depends on two things. The first x value we took, which is 1, and the last x value we took, which is 6. So basically, it is upper x value, which is 6, minus lower x value, which is 1, divided by the number of the areas we took, which is, we named that n. But how much is n here? In this question, guys, I can say that n equals to 5 because I made it 5 different areas. So that's going to give me basically, even if I want to plot that and then give you the answer, so 6 minus 1 over 5, that's going to give me 5 over 5, which is 1, actually. That's why delta x in this example is 1. If I go back and substitute, basically, guys, I'm just going to show you, because this example is the first example. I want to show you where's the idea of trapezoid coming, but this is the important things. So I know how much is my delta x. I just need to apply some of the numbers, applying some of the numbers to finish this video. Hopefully the video is not going to be very long. It's approximately over 15 minutes. But now I'm going to put that 1. So delta x is 1, and that then will be divided by 2. So f of 1, guys, you are going to use this equation, guys, by the way, y equal to the square root of x minus 1. So I'm going to find each of them. So f of 1, if I substitute x equal to 1, let's say x equal to 1, I will get here 0. And before that, guys, by the way, let me just show you something else, because that's make my equation nicer, maybe. Let me rewrite the equation. I'm just going to clean this part here, and I will rewrite this equation because it's better to make it in a nicer way. So I will say that area of the trapezoid, all of the trapezoid I have, it's the delta x. We know that. That's going to be, sorry. And then now we have f of 1. That's the first one. And I have 2f of 2. So it is 2f of 2. And then 2f of 3. And then 2f of 4. And then 2f of 5. And then only f of x one time. So the first one and the last one is going to be repeated only one time. And if I make this inside a rectangle to make things easier for me to see that, and that's, let me just try to move it a little bit and then make it in a nicer way. And then I can just make it bigger. Maybe I put this line in here. And that's my law. Okay. So if I just try to write it down this piece in a nicer way. I just want to put everything inside the red rectangle, guys. I want to make it nicer. I just have a delta x divided by 2 in here. That's it. Now, guys, as I said, that y is equal to square root of x minus 1. I'm going to write down that the area of the trapezoid solving this question. We said that delta x is 1, so 1 divided by 2. F of 1, substitute 1 here. So f of 1 was going to give me 0 times 2. F of 2, if you put 2 here, it's going to be 2 minus 1 under the square root. So that's going to give me, actually, I can put it here so people can see that instead of having problems of understanding the steps here. So I can say that it is 2 times the square root of 2 minus 1, and then plus 2 times the square root of 3 minus 1 plus 2 square root of 4 minus 1, and then plus 2 square root of 5 minus 1, and plus only square root of 6 minus 1. Well, as you know, guys, if I just rewrite this one here, that's going to be square root of 1 minus 1. And then that's a 0, of course, yes. So let's rewrite that and try to find the total value of this to finish this video, guys. So 1/2 is going to be here, and that's going to give me 0 plus 2 times square root of 1 is just 1, and then plus 2 times square root of 2, and then plus 2 times square root of 3, plus 2 times square root of 4 means 2, and then plus square root of 5. So we close the bracket in here. And if I just substitute all of these, we will get the answer approximately after all of this. So that's going to be a 1/2 times all of these. If I just make the calculation, total calculation for all of this, I think I can count it if you give me a minute. So that's going to be 4, 6, 2 square root of 2, 2 square root of 3, 2 square root of 5. So the total is going to be approximately a 7.26 unit squared. So that's actually the idea of the example. And we can always, guys, try to use this. This is a good approximation. It's actually a good approximation for any of the questions we want to apply by using the trapezoid method. And then if you can see that, guys, I'm just trying to see if we can find exactly the area under the curve using the direct integration. I can make that also for you guys. So the total area is going to be this way. I'm just going to show you the idea. The idea is a equals to the integration from a to b, and we know that a starting from 1 and b is going to be 6. F of x, which is, we know that it's a square root of x minus 1, that's y2, as I showed you guys previously. Well, let me make it this way so people can see that, because it's not going to be any. So from a to b, and then I have a y2 minus y1, and then I have a dx. So I can make that exactly and see how much is the difference between the trapezoid method and this method. So I have it from actually from 1, because my lower is 1, and then the other one is 6, and my y2 is a square root of x minus 1. And my y1 is actually x-axis, which is y equal to 0. And then all of this is going to be multiplied by dx. All of this is going to be multiplied by dx. And I will multiply this by dx. The top part here should be 6. Looks sometimes strange, the numbers. So I'm going to have it integration from from 1 to 6. Just going to make it this way, guys. 1 to 6 in here. And that's going to be x minus 1 to the power of 1/2. So times delta x. Well, guys, integrate this. It's easy. We just can say that let x minus 1, or let u is equal to x minus 1. u equal to x minus 1. So du over dx is going to be 1, which means according to this relation, du equal to dx. So I'm going to make it here 0 to, sorry, again, it is from 1 actually, because that's a lower uh, value of our integration to 6 here. And that's going to be u du. So u to the power of 1 half du. So that's going to give me add to the power 1 and divide by the new power. So that's going to be u to the power of 3 over 2 divided by 3 over 2. And this is going to be from 0 to, sorry, again, from 1. I used to start from 0, guys. That's why, from 1 to 6. If I just want to continue this integration, so the situation is going to be 2 over 3. Take the reciprocal of the bottom, and the bottom is square root of, well, 2. Let me just make it here. U is actually x minus 1, so that's going to be x minus 1 to the power of 3 over 2. And we are going to substitute 1 to 6. So taking away, and 2 over 3, I can rewrite it here and just make this 6, substituting 6 first. So I'm going to make a 6 minus 1 to the power of 3 over 2 minus 1 minus 1 to the power of 3 over 2. 1 minus 1 to the power of 3 over 2 is going to be 0. So we are going to have only one value in here. I'm just going to go down to finish this integration. Hopefully the answer is going to be close to the trapezoid method we did. So 6 minus 1 is going to be 5. And that's going to be 5 to the power of 3 over 2. Now we need to find the value of 5 to the power of 3 over 2. If I use a calculator, maybe. If I use a calculator, and I will take it 5 to the power of 3 over 2 means 1.5. You know that. And I will make it approximately 11.18. That's going to give me 2 over 3 times 11.18. If I go back to the, and then multiply this number 11.18 by 2, that's going to give me 22.36 approximately, then divided by 3. So that's going to give me exactly 7.453. 7 approximately, not exactly. Well, that's going to be 453 unit squared. And I think this is very close to the number we got from the trapezoid. That's going to be 7.26 units squared. That's going to be 7.453 units squared. So you can see, guys, from this relation that normal integration and the integration using the method of trapezoid is going to give me very close answer. This is actually the steps we need. We need to define delta x from the beginning. So general law for the delta x, as we know, it's I can summarize that the delta x, the most important part to find in trapezoid method is delta x equal to b, which is the upper part of the integration, minus a, which is the lower part of integration, dividing by n, and n is the number of the divisions that you are going to divide your area under the curve with how many areas you are going to divide it. This is actually the base of the idea. Other than that, the trapezoid area will be given by AT trapezoid. So it's going to be delta x over 2. That's a general law. And then we have f of x naught, which is the, or f of a, basically. Let's just make it this way here. Let's say that this is f of a plus 2 f of, well, the first one is a. I'm just going to make it this way here so people can see that. And then we are going to add f of a plus 2 f of, then we are going to add all of these numbers, multiple of the numbers we have. So basically, I can rewrite that as an f of x1, double of that, and then 2f of x2, and then so on until we get the last one, which is f of, and the last one is going to be f of xn. So that's going to be f of xn, and this is, we close this bracket. This is the idea that we are going to have these two pieces of the questions. Other than that, the rest is going to be just application of having this. Thank you so much, guys, for today. Hopefully, you got a good benefit from this video. Thank you.